Welcome to today's ArXiv CS Digest for April 24th, 2026. We received 512 new computer science papers today across 49 subfields. Let's dive into the top picks. Trend 1 of 5, Computational Theory and Quantum Algorithms. This trend explores theoretical computation and quantum algorithms for complex problems, from logic and algebra to physics and networks. This cluster covers 80 papers. Representative work includes Boolean PCSBs through the lens of Fourier analysis, an undecidability proof for the plan existence problem, and end-to-end performance of quantum-accelerated large-scale linear algebra workflows. Trend 2 of 5, LLM Semantics and Language Models. This trend explores LLM capabilities, applications, and challenges from efficiency and deployment to ethical considerations and linguistic analysis. This cluster covers 141 papers. Representative work includes Beyond N-gram, data-aware X-gram extraction for efficient embedding parameter scaling. How do AI agents spend your money? Analyzing and predicting token consumption in agentic coding tasks, and representational harms in LLM-generated narratives against global majority nationalities. Trend 3 of 5, Machine Learning Optimization and Theory. These papers explore efficient and theoretically grounded methods for improving machine learning model performance and understanding. This cluster covers 100 papers. Representative work includes Spend Less, Fit Better, Budget-Efficient Scaling Law Fitting via Active Experiment Selection, Optimal Lower Bound for Online Multi-Calibration, and Relaxation-Informed Training of Neural Network Surrogate Models. Trend 4 of 5, AI Agents and Decentralized Systems. This trend explores autonomous agents interacting within decentralized systems, focusing on their goals, control, and real-world applications. This cluster covers 89 papers. Representative work includes Agentic World Modeling, Foundations, Capabilities, Laws, and Beyond, Code for All, educational applications of the Vibe Coding Hackathon in programming education across all skill levels, and initial results of the Digital Consciousness Model. Trend 5 of 5. Robotics and Multi-Agent Prediction. These papers explore advanced AI for predicting complex behaviors, from robot actions to human trajectories and anatomical changes, often using multi-agent or generative approaches. This cluster covers 102 papers. Representative work includes FlowForge, a staged local rollout engine for flow field prediction, recent advances in multi-agent human trajectory prediction, a comprehensive review, and evidence of an emergent self in continual robot learning. Up next, our first paper out of 5. How vulnerable is my learn policy? Universal Adversarial Perturbation Attacks on Modern Behavior Cloning Policies by Concha Kulra and Daniel S. Brown from University of Utah. Let's break down its key contributions. This paper provides the first comprehensive investigation into the vulnerability of various classic and modern behavior cloning algorithms to adversarial perturbations. The study reveals that most existing imitation learning methods, including diffusion policy and VQBT, are highly susceptible to adversarial attacks, even black box transfer attacks. The research systematically compares the effectiveness of white box, gray box, and black box adversarial attacks against a range of popular imitation learning algorithms. Up next, our second paper out of 5, NiuTrans.LMT, Toward Inclusive and Scalable Multilingual Machine Translation with LLMs by Yingfeng Luo and Jingbo Zhu from Northeastern University. Let's break down its key contributions. Identifies and explains a failure mode in multilingual supervised fine-tuning where performance on reverse translation directions degrades due to excessive many-to-one mappings. Proposes 2 novel methods, SD to mitigate directional degeneration and PMP to enhance cross-lingual transfer and enable test time improvements. Introduces NiuTrans.LMT, a suite of large-scale multilingual translation models covering 60 languages and 234 directions, demonstrating competitive performance with smaller model sizes. Up next, our third paper out of 5, Large Language Models Decide Early and Explain Later by Ayan Dutta and Alexander Meller from IIT Hyderabad. Let's break down its key contributions. Investigates when large language models determined their final answer during chain-of-thought generation, finding that answers are often fixed early in the reasoning process. Quantifies the significant number of reasoning tokens generated after the final answer is determined, highlighting potential for inference cost reduction. proposes and evaluates early stopping heuristics that halt generation once the answer stabilizes, demonstrating substantial reduction in reasoning tokens with minimal accuracy loss. Up next, our fourth paper out of 5, toward principled LLM safety testing, solving the jailbreak oracle problem by Shuyi Lin and Chung Tan from Northeastern University. Let's break down its key contributions. Introduces and formalizes the jailbreak oracle problem, defining it as determining if a jailbreak response can be generated above a certain likelihood threshold for a given LLM, prompt, and decoding strategy. Presents BOA, the first system designed to efficiently solve the jailbreak oracle problem by employing a two-phase search strategy: breadth-first sampling and guided depth-first priority search. BOA enables rigorous LLM security assessments, including systematic defense evaluation, standardized comparison of red teaming attacks, and model certification under extreme adversarial conditions. Up next, our fifth paper out of 5, pre-trained large language models learn hidden Markov models in context by Ijia Dai and Jennifer J. Sun from Cornell University. Let's break down its key contributions. This paper demonstrates that pre-trained large language models, LLMs, can effectively model data generated by hidden Markov models, HMMs, using in-context learning, ICL. On various synthetic HMMs, LLMs demonstrate predictive accuracy that closely approaches the theoretical optimum, showcasing their capability in learning HMM structures. The research provides practical guidelines for using ICL as a diagnostic tool to uncover hidden structure in complex scientific data, with competitive performance shown on real-world animal decision-making tasks. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.